Hello again. This is Ram Seshan continuing the lecture that I left last time. Last time I gave some introduction about natural language processing, artificial intelligence, how natural language processing can be processed using some of the artificial intelligence techniques, using some neural networks and so on. So this time we'll start diving deeper into what can be done with a corpus of text, and then we can talk about how those texts can be converted into various forms so that it becomes amenable for processing and getting more inference from the text and so on and so forth. Okay, so I'll quickly go through the slides that I have so that we get to know what we're going to be covering in this class. Okay, so I'll be talking about the goal. This we'll keep revisiting every now and then. What is the goal of the natural language processing? And then we will talk about whether it is really hard to do some processing or not with the natural language text. And then we'll also talk about why is it really hard. And then later we get into some corpus which is going to help us in terms of identifying the structures within the language, finding some patterns within the language that we have, and then figure out how we can really get the meaning of the word within a given context and so on and so forth. Right. Then we will talk about typical NLP task that we will perform using the operation that we have performed using some statistical methods and so on. Later we'll talk about some simple applications that can be created using the processes that we spoke about earlier. And then we talk about the real corpus, what should be the ideal corpus that we should have. We also talk about some of the corpuses that are available right now for us to do some processing. Then we will talk about what are the operations that we can perform on a text corpus. And then later we talk about incident matrix, we'll talk about term document binary incident matrix, we'll talk about the words and terms and the frequencies for each of the terms. We'll also do some small demo to identify what can be done with the terms or words. Then we'll talk about the bag of words as another example of collecting the word frequencies and so on. We'll talk about some empirical relationship like type token ratio. We'll talk about inverse document frequency. We'll talk about we'll talk about some empirical laws like Zipf's law. We'll talk about the extension of the Zipf's law using Mandelbrot approximation. Then we'll speak about another estimation process using Heap's law, and then finally there will be two exercises that you can go back and then perform on your computer. All right. Okay. So let's start with the goal. Okay. The most important aspect of any natural language processing is to process and harness information from a large corpus of text with very little human intervention. Please underline the word very little human intervention. So we want to be able to process a huge corpus and then capture information related to how frequently certain terms occur, how frequently certain combination of words occur. Okay, so this we will keep revisiting every time when we talk about an important concept in natural language processing. Language processing is really hard and requires some contextual information to each and every one of the sentences that we speak and write. To give you an example, let's take the first bullet point. What is added with 15 to get 45? So if I ask a fourth grader who understands this problem, he will be immediately doing 45 minus 15 and then give you the answer. But when you ask the machine to do this, there is no contextual information related to a subtraction in this. So we have to really give some additional information so that machine finds the answer by subtracting 15 from 45 to get the answer. Okay. So, we do not have a clear cut definition or idea in terms of what should be done with this unless you understand the context very well. So, let us take the next example, juvenile court to try shooting defendant. So, you can form the sentence in two different ways. One, you can mean that juvenile court is going to start the trial for the shooting defendant, right. That is one way of doing it. Second way of looking at this, juvenile court is going to shoot the defendant. So, but we know that since this is going to be a court, it is only going to go for a trial, and we know only one meaning of, we take only one meaning out of that. We do not take the second meaning of that. The third one that we are going to be looking at is safety experts say school bus passenger should be belted. So, we know that this particular sentence means that every passenger in the bus should be wearing a seat belt and not like beating with a belt and all that, right. So, there is some kind of a confusion when you look at these sentences. So, how are you going to teach the machine to understand the meaning only in one way, right. And you take the fourth example that we have here, the king saw a rabbit with his glasses. Again, there are two ways of representing the same. One is the king saw the rabbit with his glasses. Second one, the king saw the rabbit carrying his glass, right. So, again we should be able to give some context to the system so that it only means one thing. The last one is again having two different meanings. One is the local high school dropouts cut in half. So, we know that by the experience of reading so many school related information, the dropout percentage is reduced, is what we really mean from this sentence. It is not really in terms of cutting somebody in half. So, the context and the kind of information that we know based on what we have learned so far come into the play when we want to interpret this sentence, right. So, it is really hard, natural language processing is a hard problem. So, we should be able to provide the contextual information to the system in such a way that it is able to interpret these sentences as which I have given as examples in the right way. Okay. Let us find out why it is really hard. We have seen in the previous slide that there are multiple ways of representation of the same scenario. In the previous case, we had shown at least two different meanings for the same sentences. It includes common sense and contextual representation. For example, in the first case of the example, what is added with for 15 to get 45. So, we need to understand it is a mathematical problem, and we need to understand there is subtraction involved in this, then only you can solve the problem. Okay. So, we need to have some common sense and contextual representation to be made available so that machine is able to solve that particular example. Complex representation of information. So, some people use very hard vocabulary in their sentences. It's every time you need to really look into the dictionary to understand the meaning of that. Some use very simple common vocabulary, so it becomes easier for us. So, it should be possible for you to interpret the meaning in two different ways. One is you can look at the dictionary for the meaning to figure out what it is, or in most cases what we do is looking at the context and the surrounding words and the common sense that we have, we try to interpret the meaning of the word that we do not really know, right. And then in some cases the visual cues are used. For example, you remember there was the color of the balloon that was flown yesterday. So, that visual clue is coming from what I saw yesterday is part of the sentence, which is not known directly to the system. So, how do we provide the visual clues or cues to the system? And sentences are ambiguous in nature. We saw through the 5 examples in the previous slide. We use idioms, metaphors, sarcasms, double negative, etc. They make the interpretation very hard for automatic processing. For example, if somebody says something that you do not approve of, instead of saying you do not approve, you say yeah, right, kind of sarcasm that you use. So, it is very difficult to bring in that kind of interpretation into the machine, because yeah and right both mean a positive thing. You are not really negating what the other person is saying. So, this is again a difficult problem to address. We have seen so far that the human language interpretation depends on real world common sense and contextual knowledge. So, without any of these, it is going to be hard for the machine to interpret these. So, where do we get these information, contextual clues, knowledge about the language? Where are they going to come from? So, it is going to be coming from a large language corpus. So, remember when you were a child, nobody taught you how to really form a sentence using some syntax of a language, right. So, you have learned to speak a language based on what you heard from your parents, your peers, other children, and so on and so forth, right. In the same way, is it possible for us to really learn the language from a large corpus that contains the representative representations of what we use on a regular basis or on a daily basis? We will now look at what could be the ideal properties of a language corpus, and then see what is available to us in the later slides. In general, if you want to define what a corpus is, it is a collection of a written text in a digital form. You can consider all the HTML files in the internet as a collection or as a corpus. And if you want to still narrow it down, you can bring in all the collections related to kinematics in physics. Could be one small subcorpus that you can look at. Or you want to look at only the mobile reviews from all the internet pages. That could be one of your corpus where you want to perform some operations related to mobile, finding the reviews, sentiments, what mobile you want to buy, and so on and so forth. The corpus should be useful to verify a hypothesis about a language. To give an example, to determine how the usage of a particular sound, word, or syntactic construction varies in different contexts. I will give an example for that. The boys play cricket on the river bank. So, we know very well that the boys are really playing the cricket by the side of the river. It is not really, the bank does not mean here the place where you go and then do the financial transaction. The next sentence says the boys play cricket by the side of a national bank. So, you know very well that they are not playing cricket by the side of the river now, they are playing cricket by the side of a bank. So, these two contexts are very different, but the playing cricket is our central context, right, this central to this to these two sentences. So, by looking at the word surrounding play cricket, we are able to find out whether they are playing by the side of the river or near the nationalized bank and so on. So, it is very important to know what the context are and what the word really means in every context. And so, in this context, the bank meant two different things, right. So, this is called the polysemy in the linguistic terminology. We want to have a corpus that contains large vocabulary. That means, it contains almost every possible word that we use in a given language. The next one, we also know that the language changes with respect to time, new vocabulary is added every year, at least 20, 30, 100 depending on how new words are invented. So, this corpus will change with respect to time. So, we should be able to provide the ability to make changes to it. A corpus should be large. If we need to have a really huge corpus so that all kinds of representative words, the sentence formations are represented within the given corpus. We want to have a corpus where the text is distributed in a uniform fashion. We want to have a corpus that covers all areas in a given language, right from the politics to news to science to technology and everything. The access to the corpus should be easy and in a simplified manner through some ways. Okay. So, this is the very ideal representation of a corpus that we are looking at, but in a real practical situation we may not have all of these. We may lack certain aspects in the real corpus that we are going to be dealing with. So, when we do natural language processing on a corpus which is not really ideal, errors do occur. Okay. So, to have a good corpus, so we need to be able to represent all the words including the synonyms and the polysemy words and so on and so forth in a very clear fashion. So, in this case what you are seeing is the disambiguation of the word bank. So, if you go and then look at the WordNet, which is a freely available thesaurus for digital dissemination of information, you will find various meanings represented for banks. So, what normally linguists do is look at the entire corpus and then find out how differently they are used, how differently the words are used, how these sentences are constructed using a given word and so on, and then finally list them in some fashion. So, what you are seeing in this particular slide is the listing of the word bank in a thesaurus. For example, in this case if you look at the meaning of the word in the first case, it says sloping land. This is one of the meanings. The slope beside the body of water. So, what has happened here is in a corpus the linguist would have found the use of banks in different fashion. So, he will go and then look at and analyze how that word is used and then create a synset for a given word. In this case it is bank. Okay. In the same fashion he goes and then looks at the meaning of the word in different context and then arrive at various synsets. So, the second one is bank is, we all know very well that it is a financial institution that accepts deposits and channels the money into lending activities. It is one of the meaning of the bank that was found through the corpus. And there are several other meanings. See, for the bank in the plane means a different thing, right. So, you laterally move the plane, it is a flight maneuver. We have different other meanings, like for example have confidence or faith in is another representation of the same word. So, a corpus should be able to provide these kinds of contextual information so that the meaning can be obtained from every context. So, what are the typical operations that we can perform using the corpus that we have in hand? I mentioned earlier that corpus is a representative sample of the entire language for a given domain. Suppose I want to find a document based on the keywords, and the keyword is very different from what is available in a document. For example, I want to search a document that does not contain the word computer, but contains only the word machines, and I want to still be able to get the documents where the machine is used instead of computers. So, when I use a corpus where the machines are used in the context of computers, the machine would have gotten sense that what I am trying to search is a computer and just not a lone machine. So, it will go and then bring all the document that contain the word computer and machine. So, this is one example of finding the information from the set of documents. And then I also have a need where I want to only extract the name of a person, date mentioned in a document, company name, the city name, and so on. So, I want to only extract that information. So, I would be able to go read, find out these info and then retrieve the document and the related information along with that. Get me all the document where cities are mentioned. Okay, I am not mentioning any name of the city here, I am only mentioning in general. Get me all the documents where cities are mentioned. So, what the system should do is should be able to go through the entire collection and be able to find out document that contain the names of the cities, for example, Chennai, Bangalore, Trivandrum, Hyderabad, Kolkata, and so on and so forth. So, all document that contain the name of the cities or town should be brought out through this. So, for that you require a corpus that would have contained all the details related to the cities, and the cities are tagged in the document. That is why you should be that's when you should be able to extract the information from that. And then we want to generate the language. This is one of the scenario wherein you have been given a photograph and you want to provide the title for the photograph. So, what you do, you normally look at the photograph and then see what are all the objects that are available in that, and then string the words related to those objects, and then finally provide a title to that. For example, if a classroom photograph is given, you have a blackboard, you have a projector, you have a professor standing in front of the students and so on, right. By looking at the photographs, you know that there are students, there are benches, there is a professor, there is a blackboard and so on. So, you would name the photograph as a classroom in general, right. So, for me to do that, I should be able to know what are all the objects that comprise a classroom. So, by looking at what I have extracted from the photograph, I string those words and then finally figure out what could be the title for the photograph. This is one of the interesting example that you will find in computer vision and natural language processing combined. Okay. And then if you are given a huge collection of documents, you want to segregate them automatically in terms of the words that contain in each of the documents. So, that is called as clustering. This is an automatic process. You do not tell the system that get me the documents related to physics, get me the document related to chemistry, get me the document related to maths, like that. So, it automatically goes and then forms a cluster of documents and then give it to you, that this particular set, this particular cluster contains document wherein these words are found frequently. So, you go and then name that later. Okay. So, the next one is text classification, where you provide the label, you tell that these are all the words that I want you to find, and when you find this document class, provide the name of the class as physics, chemistry, maths and so on. So, the bucket names are known, and using the words that are frequently found in the document, the documents are moved into the respective buckets. And then the last one is, I am sorry, then we have a machine translation. This is a very interesting task in the natural language processing, where you want to be able to translate from one language to the another automatically. So, we will talk about this in our later classes. And then the grammar checkers. I am sure some of you or most of you might be using the web based or the cloud based grammar checkers. So, what they normally do is they just when you type a sentence, it finds this error in your sentence, or if there is spelling mistake, it's identified, and so on and so forth, right. So, again, for you to do a good grammar checker, a very ideal English language text or any other language corpus should be made available. Okay. So, let us move on to the application for that. So, we have spoken about what we can do with a corpus. So, now we will find out what kind of application that we can build. This is a very crucial thing that is required for the human. We want to build applications so that a lot of things can be automatically picked up. So, the first one is going to be sentiment analysis. Sentiment analysis, I am sure all of you would know, like to find out whether the review of the movie is positive or not, whether it received 1 star or 5 stars, or is it a good movie or a bad movie, that actor is a good actor or a bad actor, or is an average, and so on. So, we want to be able to read the reviews and automatically find out whether the review provides a positive analysis or a negative analysis, whether it gave the positive results or the negative results. Okay. And then you are very familiar with the second one, which is the search engine. I am not going to be talking about this in detail. The third one is news curation. News curation is again something you would have seen on your mobile phones. If you keep reading certain news items that are available on the main page, it starts recommending certain news items automatically based on what you have read earlier. So, the news curation is either it finds out what is your interest based on what you have been reading over the last few months, and starts recommending articles related to what you have read so far, or it can also request you to say, okay, would you like to read articles related to cricket written by certain author, or you want to read articles related to some political news written by certain author. So, these are all the news curations or the content curation that you can develop based on the natural language processing. I spoke about the automatic machine translation. I am sure you also know about this very well. Most of the mail that we receive nowadays on our public email addresses are spams. Only about 2 to 3% of the mails are very useful to us. Rest of them are all spams. So, there is a mechanism by which the email providers create this spam filtering and automatically move the emails into this spam folder. If they are not able to do it, they also request you to mark certain emails as spam, so that next time when a mail of that type comes, it automatically goes into the spam folder. Transcription of text from audio and video. For example, so I am now making a presentation and then speaking in English. Is there a possibility of the machine reads the audio and then finally transcribes the audio into the text format automatically? Again, this requires a good amount of corpus in the language and also in the subject that I am talking, so that the sentence formation are legally correct. The last one is the chatbot. The chatbot is something which is an emerging area where people would like to provide the experience of talking to a machine and provide the same experience that you might get from the human on the other side. So, this is again an application that requires a lot of expertise and contextual information, so that it is able to provide meaningful transactions with the one who it is talking to, right. Okay. Let us now look at some of the lexical resources that are available, and you will also find lot of them in the internet, so that you can make use of that for your natural language processing. So, as I mentioned earlier, that a corpus is a collection of machine readable text collected according to certain criteria. So, I can collect a corpus for a given domain. Maybe if I want to only talk about something in the natural language processing, I can collect all the documents related to that and then keep it as a natural language processing corpus. By creating a corpus, we assume that it provides some representative collection of the text, right. We want to perform some statistical analysis and hypothesis testing on the corpus. We want to validate some linguistic rules within a specific language using the corpus. So, these lexical resources which are now available for us to do the natural language processing are given on the right side. So, we have a Brown corpus which contains the collection of written American English. This may not be suitable for British English as well. It is very specific. Look at this, you know. So, this is collected according to certain criteria. There is a subset of Brown which is freely available that we can make use of. Bilingual parallel corpus, Canadian Hansard contain French and English transcripts of the Canadian Parliament. There is a Penn tree bank that contains annotated text from the Wall Street Journal. You will also find many corpus for learning purposes from the platforms like Spacy and NLTK. So, if you have a collection of text, then it should be possible for us to do some statistical analysis on it. We can try some neural net based model, build a language model. So, all those things are possible only if you have a good corpus. So, it is important for us to identify what we want to do and then get the corpus and start working on it. Okay, so we spoke a lot about what a corpus is, and now we will talk about what kind of operation that you can perform on a corpus. So, the corpus contains the text which you can process using your normal application. So, for example, if you use the grep, a regular expression pattern identifier, you should be able to find out a word, a number, a date, email address, and so on and so forth. So, that is one of the fundamental requirement in the natural language processing. So, I should be able to identify few patterns. For example, I want to capture 2 words at a time, 3 words at a time, and then I require some kind of a pattern matching algorithm to get that. We require a very fundamental program that extract tokens. A token is something that is separated by a boundaries. The boundary is sometimes a space, a period, a comma, and so on and so forth, right. So, I want to be able to extract a token based on some boundary conditions. I want to find out the number of tokens or words in a given document or in the entire corpus, and you want to find out what is the vocabulary count in that. The vocabulary is nothing but the unique words that are represented in the corpus. You want to find patterns of words. For example, I want to find the twin words like in New York, New Delhi, hot dog, something like that. So, you want to be able to find them out using the corpus that you have. You want to find the co-occurrences of words. So, I always want to find 3 words at a given time. So, if I have a small window where there are 3 holes, and then I use that window and move it across the text, every time when I move from one word to the other, I capture 3 words. So, this is the co-occurrence of word that we are talking about. So, we will talk about this in detail as we move along. So, the basic operation for all of this is an operation called tokenization. So, most of the applications or the platform provide this functionality. So, we do not have to really write code to do the tokenization. So, this is a process where you divide the input text into tokens words by identifying the word boundary. Okay. So, these are the fundamental operations that you want to perform on a corpus.